Hi and welcome to this video where I would like to look at further examples of numerical interpolation. So in here, just to save time, I already drew the table, and we would like to evaluate the function at x equals to 15. We'd like to evaluate the function f of x at x equals to 15 using the table below. So for the table below, we have the values of x, x values here, okay, and then we have the corresponding f of x, okay. Oh, sometimes we're using y is equals to f of x. In other words, we have our y naught, okay. In this case, this is y naught, but in this case, which is f of x0, okay, this is f at x0, and so on and so on. And then this is the first difference, this is the column for the first differences, and then this is the column for the second differences, the third forward differences, and the fourth forward difference. So if we would like to, for example, get a polynomial of degree 4, okay, we are going to solve this by creating a polynomial of degree 4, okay. So in here, of course, we would like to evaluate if we want to find f at 15, that is f at x equals to 15, x equals to 15. So we can start by now filling out our values. We have that our x value is 15, our x naught is 10. This is our x value, x equals to 15, okay, and this is our x naught. All right, x naught is 10. Step length h is it's uniform here. You can see it is 10, 10, 10, and 10, okay. So h, we can say it is x1 minus x naught, which is going to be 20 minus 10, and we have 10, okay. What is r? We know that r is given as x minus x naught over h. Our x is 15, minus x naught is 10, divided by h, which is 10, and we get 0.5. Okay, what is our f naught? What else do we need? F naught is what is f naught? F naught is 46. Okay, so we have f naught is 46, and then what is the first forward difference at x equals to 0? That is f naught, that is 20, okay, this here. This is 20, and then similarly from the table you can see that the second forward difference at f naught is -5, and then the third forward difference is 2, and the fourth forward difference is 3. So the values here we are using are simply these values here, this, okay, the forward differences that we are using. Alright, now I think we have all the information that we need here, because sorry, is this 3 or -3? Just a minute. Okay, sorry. Okay, yeah, it is 3, the fourth forward difference. Yeah, please, you'll check, this example is in the notes, so you will check for any error or any mistake in these values. You will check, okay, if they are maybe a negative missing or something of that sort. But I hope all is okay. All you need to know is extract that information, and then we can now simply use our formula here, f of x, okay, which we are going to approximate with the polynomial of degree 4, and in this case which we have equal to f naught plus r times the first forward difference plus r into r minus 1 times the second forward difference divided by 2 factorial plus r minus 1 r minus 2, the third forward difference divided by 3 factorial, and then lastly r into r minus 1 into r minus 2 into r minus 3 times the fourth forward difference over 4 factorial. Okay, and then the rest is now simply substitution, because we have all the values we need here. We have our f naught, okay, it's here. We have our r, we have it, okay, it's computed here. And then yeah, the rest is just simply substituting. You can please substitute in here and then get the values here. So you simply substitute, okay, and then yeah, you simply substitute. Maybe here just so maybe we can write this as we can say this is f at x equals to 15, okay, and then this is at x equals to 15. Why? Because we already computed using the value of x equals to 15 to get this value for r here, okay. So I suppose you can follow through the example, because the rest is just substituting and then you get the value, okay. So similar to it, we would like to find the cubic polynomial which takes the following values. So we are given the values: f at 1 is 24, f at 3, f at 5, and f at 7. So we draw our table here which has our x values, okay. Then the corresponding values are given to us, function values, and then we have our forward differences here, the first, the second, and the third. So we'd like to find a polynomial of degree 3. Again, we simply extract our information. So if we can go through this very quickly, we see that the step length is 2, okay. So h is 2, our x naught is 1, what else, our r, okay, it's just general. If we want to find the polynomial, so it is general x minus x naught, but x naught we have it, so it is x minus 1 over 2, okay. So we'll find our f of x. We can substitute into the formula. We have it is f naught plus r times the first forward difference plus r into r minus 1, the second forward difference over 2 factorial plus r minus 1, r minus 2, the third forward difference over 3 factorial. This is a polynomial of degree what? This is a polynomial of degree 3, okay. So the rest we can simply substitute. We have f naught. What is f naught? F naught is 24, okay. This is the first forward difference, second forward difference, and third forward difference. So the rest is simply just substitution. So you have 24, then you have so r we have as x minus 1 over 2, then times the first forward difference, which is 96. So the rest is simply going to be algebra. R into r minus 1, okay, times 120 over 2 factorial, which is 2, plus r, okay, into r minus 1 into r minus 2 times the third forward difference over 3 factorial, which is 6. So you can please verify, okay, do the algebra and verify that f of x, or this polynomial of degree 3, okay, which you can approximate with a polynomial of degree 3, is given as x cubed, the result from this, okay, x cubed plus 6x squared plus 11x plus 6, for which, if we want to find, because they said we will find a cubic polynomial, hence or otherwise, we would like to find the value of f at 8, hence or otherwise obtain the value of f at 8. So it is simply just plug in now. So you can simply say that f of 8 can be approximated with a polynomial of degree 3 at the point x equals to 8, which is that plus 6 times 8 squared plus 11 times 8, then plus 6. Okay, so we have seen two examples here. All you need to do is to set up the table, and then you do what? You substitute accordingly. Okay, thank you, and next time we are going to begin with the Newton's. In the next video we shall start with the Newton's backward interpolation formula. Thank you, and see you in the next video.